Noah is an associate professor of computational media, which is a new thing at the University of California, Santa Cruz. I don't know if you're going to talk about that, about the computational media. And he co-directs the Expressive Intelligence Studio, which is one of the world's largest technical research focus centers looking at games. He also directs the Playable Media Group and at UC Santa Cruz's Digital Arts and New Media program. Noah's worked in a bunch of different areas ranging from game art, narrative in games, to various sort of technical aspects of games. And he's also partly responsible for one of the most important books that MIT Press ever published, the New Media Reader, which I recommend to you if you have any interest in new media. You might also want to take a look at his book, Expressive Processing, Digital Fictions, Computer Games, and Software Studies, which was also published by MIT. So Noah, take it away.
So thanks for the introduction. Thanks for having me here. I plan to talk about a lot of ideas quickly, and then hopefully by doing that, preserve time for questions and discussion, which if anyone feels like one of them was given really short shrift, will allow us to return to it, but also will allow us to maybe build and go in new directions if people are interested. I hope this is an uncontroversial statement here, right? I think games are changing our lives. Games are, doing, in the 21st century, a lot of the work to change our culture that we've seen from other media in previous centuries. I hope this is also an uncontroversial statement, right? If we could travel back just a few decades, the idea of playing games on devices like this, or playing games with devices like the Kinect, or playing games of the sort that people play on social networks and so on, would all seem extremely weird, right? There's not some stable thing called games. We're not all of us playing more asteroids than we used to, right? Games are changing, and that's part of how they're becoming more influential in our lives. So I think there's a question for those of us in universities, which is, how should we respond to these things? And I think there are some stereotypes that might be useful to call out right at the beginning. So for example, one stereotype is that social scientists still talk to people. They just do it in World of Warcraft. That makes it games, right? And humanities people still think deep thoughts, but they do it about Jason war games. So that makes it games research. That computer scientists still build systems. They're game systems, but they still only go far enough to publish a paper. The educators continue to educate in the same way, but now they've added points and levels. So that makes it exciting game education. Visual artists continue to make objects for galleries and museums, but now these reference game culture, so we've engaged games successfully. Game designers basically just put new skins on familiar games and thereby learn about the classics, right? I don't think actually anyone in this room does any of these things, but when I meet people out in the world and say, my university is trying to engage games, they usually assume I mean one of those 6 things. And so maybe right off the bat, I'm saying, I don't mean any of those things. I assume none of you mean any of those things, but I think it's against that background that we're defining our university response. I also want to say I don't think there's anything inherently wrong with those activities, right? I just think it's not necessarily what I want to spend my time on. Because I think because games are a new research area, we really need to address new questions and actually invent new methods. I think as a university, we want to take risks, right? Whether you have a tiny studio that can't fail or a giant AAA enterprise that is operating like a movie behemoth, risk-taking is hard in a lot of parts of the game industry. Universities, I think, exist to take risks that can lead to new knowledge. And then obviously we also educate students, and I think we want those students to be looking toward the future. And a lot of those stereotypes are really organized around the status quo or even the past. And universities actually have an awfully proud history to build on. I think there's a sense in some corners that somehow we're interlopers into games, when actually, for my money, this is the first video game, right? This is the first game with a video display played on a digital computer. This is Checkers for the Manchester Mark I, written by not Lytton Strachey, that's his uncle, Christopher Strachey. But if you're familiar with the Bloomsbury Group, yes, the nephew of Lytton Strachey. And this game not only had a game tree search AI algorithm, it also had like a proto-personality. It would make fun of you for bad moves, and if you did too many illegal moves, it would stop playing with you. And this was 1951, right? Or if you consider Space War, right, coming out of MIT, or if you consider Adventure, right? Both Space War and Adventure introduced templates that so many games since then have built on, coming out of Stanford and BBN. Or if you think about something like Mud 1 coming out of Essex, right? If we think about where games come from, the answer is actually universities and national labs. That is where the video game is born. At UC Santa Cruz, we have a particular approach, and part of what I'm going to do today is talk about our approach, which may not be for everyone, right? But hopefully holds some interest, at least for debate. So in 2006, we started an undergraduate degree in the School of Engineering. It's now the largest degree in the School of Engineering, even though it has more requirements and is and has higher average scores and blah 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 than regular computer science or anything else in engineering. We also have a PhD in computer science, where there are about 40 to 50 PhD students where computer game research is their primary focus. We also have an MFA in digital art and new media, where one of the 4 areas that students can focus is games. And we have 2 current proposals in the UC system. Starting new degrees can be pretty heavyweight. So right now we have a proposal for a BA offered by the arts division that is actually supposed to create a shared community and sense of one program with students in the BS, because interdisciplinary projects of an educational sort, I think, work best when students actually work together all 4 years and see themselves as part of one community, rather than coming together for a capstone where they tend to, I think, kind of operationalize each other. And then also for a Master of Science and a PhD in Computational Media. And that'll take about 2 years to be approved, because things for the UC system go all the way up to the central campus at Oakland and so on. Not central campus, central office of the president. So we started with interdisciplinary degree programs, and we're building new ones. Then we started an interdisciplinary research center, and this brings together people from across campus, not just arts and engineering, but also people in literature, people in history, people in theater, and so on. And then, as Henry mentioned, we started what we believe is the country's first department of computational media. So this is explicitly a home for interdisciplinary work. It was started in November. It's a very new department. It has 6 founding faculty. These are our pictures and our names. You can get a sense of when these were taken by the fact that I'm beardless. And then we're hiring this year, and we're hiring next year, and the campus has something of a commitment to build this up into being a full department with a rich PhD offering and so on. So Santa Cruz has clearly made some big investments in university research in games. And then that leads to the question that I get asked with some regularity, like how can you tell if you're making progress, right? If games are a knowledge area, as you researchers claim, what research is producing progress in that area? So one way of looking at it might be to say, like, there are computers involved, right? The founding faculty of computational media all were previously faculty in either computer science or computer engineering. So maybe this is just an engineering problem, right? And actually, problems of media have previously been sometimes framed as engineering problems. So you might be familiar with this image, right? This is the sort of first 3D human head, right? Created at the University of Utah in 1972. You might also be familiar with this face, right? This is Liza Minnelli. She won the Oscar for Best Actress in 1972. So maybe, if it's an engineering problem, we're just trying to move linearly as fast as we can from this head to this head, right? And then we can use a bunch of the techniques that we already have in computer science, right? We can optimize things and make them happen faster, so that algorithms that are out of reach become in reach for the kind of hardware we have. We can just wait for the hardware to get faster, right? We can evaluate things pretty simply, because it's like, does it run? Does it run at an acceptable speed? And so on. So basically, this is one way that you could do games research as well, right? You could define a goal, photorealism, and all movement toward it is progress. And then making new kinds of media is an engineering problem, right? Probably most of you know what slide comes next, right? This one, right? So many of you are probably familiar with this idea of the uncanny valley, right? That actually, as you get closer to photorealism, you get less engaging media, right? Something that looks almost human is more like a zombie or a corpse than it is like a more engaging stuffed animal or a more engaging robot, right? There's a sort of fundamental problem, which is that progress defined in engineering terms can actually take you backwards defined in media terms. So we need some other way to figure out if we're making progress, right? That isn't actually clear to everyone, right? So some people, even in the arts, try to make progress by going towards photorealism. And we get movies like Beowulf and Final Fantasy, which are known for being at the edge of photorealism for their periods and also known for being really off-putting, awful movies. Or you get people who instead take a different perspective, right, where they actually use more abstraction and don't necessarily aim for photorealism. Now, the interesting thing is that both of these approaches require research. Pixar does not do research, right? They just do research that is guided by something else. In this case, it's guided by art rather than the preset goal of photorealism. It's not that every step along photorealism is better, it's the step towards the particular piece of art that we are trying to make that is better. And actually, there are people who propose this sort of approach for other areas of media and other areas of computer science. So for example, you want to make characters for games that are more and more like real people. That's the equivalent of photorealism, right? The end goal of that is what? We get people who are as interesting as the random person sitting next to you on the bus, right? No, actually, to have an interesting character requires very careful script writing, requires real acting, right? We're not trying to get to the ordinary, and photorealism is another idea of the ordinary that I think we're not trying to get to. So now, what do I think we're trying to do? I think a better analogy might be something like, well, what happens when you take these two things and put them together, right? What happens when you say put biology together with computation? One way of looking at it might be to say, I'm going to apply computation to problems from biology. But that's not actually how big progress in bioinformatics gets made, right? Big progress in bioinformatics gets made by asking new questions that could only arise among a group of people who understand both domains, rather than one providing the question and the other one solving it. And I think what we're talking about here is a similar thing. The arts and humanities, the disciplines that understand media, together with computation, gives us what we at Santa Cruz are calling computational media. And it's a similar thing where you only can figure out what the questions are, and you can only figure out how to address them, and you can only figure out if you're making progress if you really take the knowledge models and the methods of multiple disciplines seriously. So another way of putting that could be, we use the techniques of computer science to create new technology, but the conception, guidance, and evaluations of project comes from deep dialogue with non-engineering disciplines. And this is something that's happened to computer science in the past, right? It's not just bioinformatics and computational media. For example, human-computer interaction, which previously went by much worse names like human factors, right? But it's about real engagement with the social sciences. It's not one providing the problems and the other providing the solutions. In our case, our particular research group is really focused on what we think are core challenges arising from today's games, right? We think there's a lot of rich technical and design work that has already gone into today's games, and by examining them and by critiquing them, you can actually see some places where work would be fruitful. One thing about today's games is the best ones, and frankly, all of them, are kind of lovingly handcrafted, right? And there's something great about this, that they're not systematic, they're not assembly line. Each piece is sort of made by a human with relatively little guidance from, say, the software they're working with. So if you think about models and animations, yes, there's some tool assistance, but each one is made individually for the most part. Stories similarly are handcrafted. Each state the story can be in and each way it can transition to another state is handcrafted. Language and dialogue, the same way, right? Basically, the dialogue systems in the games that are most sophisticated and most heavy in their use of dialogues are essentially directed graphs. You want to add one new response in there, you got to revise a bunch of stuff. Levels and challenges are handcrafted, right? So each element of the space and each way that the people you're going to engage with are arranged, all of that is done by hand by a person working in a pretty low-level tool. And what we find is that basically, because we're making lots of games and we're making big games, this handcrafting isn't scaling terribly well, right? That you can kind of lovingly handcraft a tiny thing, but when you go to the more assembly line sort of approach, where you want to say give lots and lots of possible responses, or you want to have lots and lots of games without spending a whole lot on making them, you run into problems of quality. You also run into problems of interactivity, right? This is a little thought experiment called, I believe, paper Pong, where basically instead of Pong having any physics rules built in, it's done as a choose-your-own-adventure book, right? So if you want to move up, turn to page 114. If you want to move down, turn to page 117. Okay, if you want to move up, turn to page 33, down to page 121. Oh, either way you move, you're going to lose, right? You're just too far away. Go to page 25, right? And this is how most things in games operate now, right? Physics doesn't, combat doesn't, economics doesn't, but there aren't many other exceptions beyond that, right? So, and then there's also the problem of authoring tools, right? Most authoring tools for games are really difficult to use. They require expertise, and then the thing that comes out at the other side has very limited ways it can be understood and used by the system. So we get things like role-playing game quests, where actually the complexity of the quests goes down between Knights of the Old Republic and Mass Effect, because the complexity of the quests in Knights of the Old Republic was producing bugs that could not be dealt with by the technology that was being used. Rather than improve the technology, let's just dumb down the quests. And frankly, even tools that are aimed at beginners, right? So something like Little Big Planet, where you're supposed to be able to, as a 7-year-old, create platformer levels, produces lots and lots of platformer levels that you can't play through. You have to stop and play test and stop and play test to know if you can even complete your level, right? Imagine if point and shoot cameras were like this. Well, sometimes it works, right? Or pens, sometimes the ink comes out, right? There are expert tools that are like that, but those aren't the tools we want to give to beginners. And then, as I was saying before, with the exception of navigation, combat, and economics, which are represented as systems and therefore are separated from the kind of handcrafted elements, everything else in life is essentially not represented in any systematic way. So, whether we're talking about beliefs and ideologies or human relationships or what happened to me yesterday or who I am, or many, many other things that might matter to us, we just don't have systems for them in most games. And the problem with this is, we don't have a system for ideology in movies, but this ideology in movies arises out of us watching the movie, right? Whereas the meaning that arises out of games arises through play. So if we have no way of playing with ideology, in some ways ideology is just a skin, if it exists at all, over the things in the game that actually produce our play and the real meaning of the game. So if you believe this argument, right, there's a huge amount of research questions that are just waiting for someone to address them. But they're ones that I believe need to be introduced in an interdisciplinary way, or they need to be addressed in an interdisciplinary way. And I want to talk about two of them in particular. So one of them is this challenge of authoring that I've been getting at, right? So today's authoring approaches are expensive. They really limit who can express themselves in game form, right? They're aimed at experts. They severely limit what can be expressed in games. They really only exist for things like 3D space. They don't exist for a lot of other things we might want to represent. And also they're kind of a lost opportunity for learning, right? People can learn a lot about games, about technology, about the world by making games, but they need to have a tool that works for them. Then the other challenge I want to talk about is generativity. So games with fixed assets basically cannot respond deeply to the world. And I mean that in a couple of ways. So one is the things that are happening in the whole world outside the game cannot lead to the game responding in some way. And similarly, the things that are happening inside the game, right? What has happened so far cannot produce novel responses from the game. And we might really like this, right? You know, when we deal with another human being, when we go to an improv comedy show, what was on the news might actually matter, right? When we sit down with someone who's trying to teach us something, what we just did might matter. The particular mistake we made might come up. You need a more generative approach to be able to address these things. So I'm going to talk briefly about a set of projects in each of these areas. So for example, here is an authoring project called Ematic. And it sort of starts from the question, why do people read the newspaper? Or why did people read the newspaper, right? In part, people read newspapers for play, right? Sudoku and crosswords and things like that. And also people read it for opinion, right? Short opinion pieces, editorial cartoons. These might, right, a hypothesis is these might serve a similar function for digital newspapers, but right now, news games, to the extent they exist, have to be created by experts, and they take time and money to make that most newspapers can't afford. So here's a thought experiment. What if journalists and actually just ordinary citizens could make very simple games expressing their point of view about a topic they choose quickly? Right, so this was funded by the Knight Foundation, and it's a collaboration between Georgia Tech and UC Santa Cruz. And I'll just show a little bit of a video of it in action.
Click inside the noun box to change the name of the noun to the person, object, or entity you want to appear in your games. For instance, if you're making a game about President Obama, you would name one of the nouns Obama. You can use any noun you want, singular or plural. Concise nouns will make skinning your game with images easier later on. Verbs are a little different. Ematic will generate behaviors based on the verbs that connect two nouns. Click the verb box on the arrow to enter your verb. Start typing the first few letters of a verb, and you'll see whether the system knows it. You can also choose from the drop-down list of all the verbs that Ematic understands. You can delete individual nouns and verbs by hovering over them and clicking the X button. Deleting a noun will delete all arrows connected to it. The clear button will erase an entire diagram. If you're not quite sure what kind of diagram to make, the Show Example button cycles through a number of diagrams that have generated interesting games in the past. When you're happy with your diagram, click the large Make Game button and watch Ematic do its magic. Don't worry if you're unsure about the strength of the diagram, because you can return to this screen and change your diagram at any time.
So
the first game Ematic has made for you shows up on the left. On the right are the editing tools. The title screen that pops up in the game window gives basic information about your game, tells you which noun the player will control, as well as the input method for playing. It also explains winning and losing conditions for the game.
So basically, this is a tool that allows you to create a diagram expressing your point of view about some issue, and then it rapidly tries to create a bunch of different proposed games that might express the thing that you're trying to express. It allows you to add images to them. If you don't like it, it allows you to see another, and then it allows you to publish them out to the web, right? So making a little news game goes, in this experiment, from something like a team of 3 people working for a couple of days to, 5 minutes of playing around and seeing if you can actually find a game that you think is interesting and expresses your point of view. Obviously, this requires some technical work, but it also requires humanities work, right? Where did we get the idea that different verbs could be expressed by different types of movement and collision? It comes out of game studies, right? And where did we get the idea for different types of arrangements and things to produce, right? Basically through rhetoric studies of both news games and editorial cartoons, right? So yes, this requires technology research, but this could not be done by technologists alone. And I think this kind of research is actually some of the kind that we need most. Similarly, Co2 AI Lab has a set of questions that motivate it, right? So actually, Eric, who's in the room, worked on this project, right? And it starts from another sort of very general question, right? Like, how do we get more people to understand computing, right? We might need more, and why do we need more people to understand computing? We might need more people to understand computing because they need to understand that things like total information awareness are actually technically unworkable fantasies, right? But they also might need to understand computing, for example, because we live in a society that's awash in media, and our media are increasingly computational. game making turns out to be a motivating introduction for a lot of young people to understanding both issues in computing and issues in how these sorts of media work. But game making tools and curricula often embody really narrow ideas and often appeal to sort of narrow demographics. So what we worked to do was start with Microsoft's Co2 and create a broader tool and a broader curriculum. And then we spent, we spent some money from the National Science Foundation and collaborated with ETR Associates. We also spent a couple of years. And what we did here was basically collaborate with people, yes, who can do technical research, but also with people in the learning sciences. That was a big part of the motivation for collaborating with ETR, and people who understand game design, right? You need to understand what types of broader game design you're working to make available to students before you try to make a tool that embodies them. And if you don't have that input from the arts, it's very hard to know what to do technically. Co2 has this kind of robotics-inspired language, and originally all the things at the top level were things like shooting and being shot. And we started with simple things like adding being able to speak and listen. And then we got into sort of deeper things like being able to have different levels of friendship and do different things based on the levels of friendship, things that we thought might actually be on the minds of a wide range of middle schoolers. Tanara is another project that is motivated by a set of questions. In this case, the question is, what if game makers had smart tools, right? Lots of disciplines have smart tools. Game makers, for the most part, don't, right? They might be smart about something like space, but they're not smart about how the game is played. So, what if beginning game makers had something that could be like a brainstorming partner and also could at least give a warning or maybe even fix it if things were broken, unlike what happens in something like Little Big Planet? Or, what if professional game makers, instead of focusing on questions like, is this broken or not, knew that that was taken care of and could really focus on things like, is this an engaging experience? What do I want the rhythm of this to feel like? And so on. And so this, again, is another National Science Foundation project. In this case, we made a prototype tool for Mario-style platforming games.
This is a demonstration of flip format.
Well, that was not what I meant to say. So here what you see is the person who's creating a level in Tanara just specifying 2 platforms and then saying to Tanara, okay, show me a bunch of other stuff that should go in between this. All I care about is you start here and you end here. What are some possibilities for how the level could be arranged? But another issue that we wanted to address in Tanara is that's
a demonstration of flip format.
Okay, sorry. Another thing we wanted to address with Tanara is that a lot of playing a platformer is about the rhythm in your hands, right? So when you're playing this, what you see is, oh, this is a jump over a gap, that was a jump onto an enemy, the thing before was a spring. But a lot of people, starting with like David Sudnow back in the 80s, have written about this kind of embodied experience of game playing and the connection with the controller and the rhythms that it have in it. He connects it to things like jazz improvisation, which is what he wrote Ways of the Hand about. And so here we actually try to build that into the tool, right? This insight from game studies and game design, that a lot of what's going on here is rhythm rather than geometry. So sometimes you can specify geometry and say to the tool, fill this in, but sometimes you just want to specify the rhythm. Here I want things to go faster, there I want things to go slower, and it will generate something appropriate. So again, this is interdisciplinary work between technology researchers and game design and game studies researchers who may be in the same body or may be in separate bodies. And I think a lot of times when we talk about interdisciplinary work, we tend to assume that it's interdisciplinary because we've gotten people who see the world in really different ways into the same room. Part of the point of having these degree programs is actually to graduate people who have both of those points of view inside their body already and can collaborate with other people who already have multiple points of view in their outlook. Ludocore is another project that is an authoring project, but moves into the second question I want to look at generativity. Basically asking, what if an authoring tool didn't just know about game mechanics, like Tanara does, doesn't just know about game geometry like Tanara does, but actually knows about game mechanics. So what we did was build a domain-specific language for modeling games on top of the event calculus, which allows you to do things like ask, is this game winnable in this many turns, and get like a logical no, that is impossible, or a yes, here are play traces showing how it can be done. Again, funded by the NSF. And this is really basic research on formal representation for games. Again, inspired by game studies results on how game rules function and compose together. And then the graduate student who was leading it created this art game called Variations Forever, where every time you play and complete a level, you don't get the next level, you get another game played by another set of rules. The interesting thing about this is that Variations Forever had this particular approach to generation using answer set programming that the graduate student working on it obviously knew a lot about. There was another graduate student at the University of Washington who was aware of their Refraction project, and these two happened to be dating. And this turned out to be really good because the Refraction project, which was a very applied game research project, I'd say this is applied game research. We're going to take what we know about games and apply it to people learning fractions. And this is basic game research, right? We don't know how to represent the fundamental rule structures of games. We don't know how to generate new games on the fly. Well, it turns out that the applied research project really wanted to be able to have learner customized level generation. Taking everything that we know about what you've done so far, we're going to generate the next level that we feel is in your zone of proximal development, right? It's really going to help you push your knowledge but not push it too far. And what they were doing was unfortunately failing. They were using the existing techniques, which tend to be things like depth-first search, and not finding solutions to the problem. And it turned out that the solution from the art game that came out of the basic research solved a problem that couldn't be solved with the existing techniques in an hour, in milliseconds, right? And so I'd say one thing that is true even in games, it's not just true in chemistry, is that you really don't know where basic research will take you. And that basic research might actually be the fundamental thing that applied research builds on, rather than the model I think we have now, which is that applied research in games builds on things coming out of industry. I'm running out of time, I realize, but very quickly, here's some generative projects from UC Santa Cruz addressing that other set of questions. First, talking about universities being proud of our game history. If you know the roguelike genre, that got started at UC Santa Cruz and was completed between UC Santa Cruz and UC Berkeley. More recently, there have been projects like Checkoff. This is trying to look at formal verification of software, which could make software safer, less buggy, and so on. Right now, it really requires human intelligence. You can get some places with algorithms, but you need humans, usually very highly paid humans. And the question was, what if the intelligence actually came from somewhere other than highly paid software engineers? What if we could do things like present problems like loop invariance as games that non-computer scientists could understand and play for fun? Well, that would require automatically generating these games, right? We want to be able to generate lots of games based on the problems in lots of places and lots of pieces of software. We could not handcraft them if we wanted to address this problem. So DARPA funded this, and actually we're working with Stanford Research Institute and an organization in France whose name I will not butcher. And the first game was released from this project, I think, last year. It's called Xylem, the Code of Plants. And these elements of loop invariance are presented as the elements of weird plants you're finding on this island that you're exploring. And you're also finding notes from previous explorers and kind of trying to put together their story and so on. Again, this is interdisciplinary work, right? We need people who understand things like game generation. We also need people who really understand formal software engineering and people who understand game design. A new game from this project, Binary Fission, is going to come out later this month. Spy Feet is one, basically saying, can the power of quest-style narratives be used to entice people to new kinds of physical activity? And particularly asking the question of whether customizing the quest and dialogue for each player and the places where they walk and the places where they are might be more motivating than just what a lot of games for your phones do now, which is even if they're using your location, they know nothing about your location and they know nothing about the history of how you move through that location, or little. And can we dynamically map the story and game content onto places that people actually want to walk rather than telling them where to walk? And can we create an authoring experience for these kinds of quests that still allows writers to leverage their knowledge of how to write quests and how to write stories? Another NSF project. The first thing we found out, we're still looking for funding to do the complete game. The first thing we found out in the prototype is that writers really don't want to adjust a natural language generation system by providing it templates and turning knobs. It feels extremely unnatural to every writer that we talked with to say like, oh, this character is more verbose. Instead, they want to say, here, I can show you some examples of how this character talks. And so the first thing we did was actually develop a system that can take things just written in natural language, right? So here's something from the script of Annie Hall, extract the kind of parameters that the natural language generation system needs from it, and then apply those parameters to new text like the type that is in our game, right? We think this has real promise as a way for writers and natural language generation systems, which have never seen eye to eye terribly well, to actually work together. But this again requires interdisciplinary work. You can't do this work without creative writers. You can't do this work without game designers. Prom Week is another interdisciplinary project, basically trying to ask how we take the compelling malleability of the social space of something like The Sims. You know, you can have very different relationships over time with the members of your household and people in the neighborhood and so on, and get that to but it's very abstract, right? And get it to combine with the real specific characters, histories, and language you see in role-playing games, like the kind that come out of, you know, Bethesda and BioWare and so on. So if you're thinking about what we're trying to do, like Mass Effect has very low social dynamism. Like, you know, you cannot decide that Rex is going to have a different relationship with another member of the team than he does, or than the couple that are possible for him. We want to actually not only be more dynamic than Mass Effect, but more dynamic than The Sims. And then in terms of character realization, we were less ambitious. We wanted to fall, you know, more specifically than The Sims, but significantly less specifically than Mass Effect. And so here's a brief video talking about some of what we did there. Oh,
Characters sends ripples throughout the entire social state. These ripples can have serious consequences. The cascading effects of a single social change affect the desires of the entire student body, sometimes in unexpected ways. Each time you play a prom week, you'll choose a member of the student body whose goals and desires will be your job to achieve. What's cool about social physics is that there's not just one way to achieve a goal. You can uncover your own solutions to the problems the characters face. Take Simon. Simon, like any young man his age, has a collection of personality traits and an ever-shifting mood. He also has histories and relationships with all of his classmates, which can get pretty complicated. Players will have to gain an understanding of the social state to learn why characters want to do what they do, and predict how they might respond. For example, these 5 social exchanges represent what Simon wants to do with Monica more than anything in the world. The player selects pickup line. Let's sit back and watch what happens. Uh-oh. Oh. Let's try another social exchange. This time, Simon is attempting to make out with his enemy, Nicholas. What do we think will happen? Simon was very interested in Monica, hence his desire to try a pickup line. But Monica just wasn't feeling it. Conversely, though Simon and Nicholas are enemies, Simon is friends with Nicholas's girlfriend, which could provide a common ground. Let's try it. Seem complex? Well, it kind of is. Prom Week considers over 5,000 social rules to figure out how characters will act. The resulting social exchanges are all presented in fully realized English dialogue.
Okay. So why would you build a game like this, right? Like a deep strategy game skinned with, you know, cartoonish high school students, right? It seems designed to appeal to no one, right? Well, part of the reason for making a game like this is to experiment with a richer representation of social interaction, to make it a real piece of gameplay, right? So right now, when I fail at a platformer, I feel like, I did something wrong, right? I didn't jump at the right moment. But when things go a certain way in a game story, I feel like, why did the writer do that? That was dumb. Like, I don't want the story to have gone in that direction. Well, if there's a deep enough model of social interaction and enough player control during gameplay, you might actually feel responsible for what happens in the game story. And we've started to see that kind of thing in the reviews for prom week. So for example, on Rock, Paper, Shotgun, they said, I won the game by accidentally being nice and friendly. So now I feel bad and impressed and want to play all over again. Next time I'll be looking at more upbeat solutions because the alternative, frankly, is hating myself. Rock, Paper, Shotgun is a very games-oriented site, right? From a more sort of story-oriented review, we got the temptation to manipulate these characters is enormous, but crossing that line feels wrong. In the end, I stopped playing Prom Week because I didn't like the person I felt like when I played it, and I can think of no greater compliment than that. So it might be weird to call out two reviews that both both of people saying playing this game made me feel bad about myself, right? I don't think that's necessarily the aim of research, and we've had other people say like I experienced great joy by inverting the entire popularity structure of the high school. I had no idea that was possible. Like we didn't know it was possible until somebody did it, right? But you can actually feel some responsibility for the outcome of a game in a way that outcome of a game's story in a way you just can't now. And I think that actually points to a really potentially meaningful direction for games in the future. Finally, I just want to point out some of the ways this is interdisciplinary research. So it's inspired by dramaturgical analysis, which comes out of the social sciences, but itself is inspired by the arts, and portrayals of social relationship in media, which are normally analyzed by the arts and humanities, and certainly were in this case. It was driven by the Art School of Interactive Story. It was developed by an interdisciplinary team. It was supported by the National Science Foundation. And then what it did was give us this model of social interaction that then, before the project was even completed, was taken up by the Siren project out of the European Union that was working on games to help students better understand playground bullying between people from different cultures. And then, some of you may be familiar with this game Facade, which is the first real interactive drama. That was also created by Michael Matthias, who runs the Expressive Intelligence Studio together with me. And putting together that social simulation technology with this character technology actually led to a DARPA-funded project to create interactive drama for Being a Good Stranger. So again, both of these projects, Prom Week and Facade, were created as basic research. They were driven by arts goals, though they definitely required understanding and making technology goals as well. And basically, by doing this basic research and having these interdisciplinary goals, I think you pave the way to social impact, rather than by starting by saying, we're going to have social impact, what can we do with existing technologies? Which I think actually has a very short runway. And we're doing many more other kinds of projects. So we're about to publicly release a social AI that people can use in their own games. We're doing some more authoring tool work. Together with people here at the Stanford libraries and at the UCSC libraries, we're doing a big intervention in how games are discovered, cataloged, and cited. We're doing a game about climate change, which is combining techniques for game generation and narrative generation, I believe for the first time. We've been doing some collaborations with big game studios to bring some of these approaches out into the public, and we're also doing more arts-oriented projects. So this is a project led by a couple of PhD students in the lab that is really trying to make story generation into a new type of gameplay and use it to connect a physical book and a reading experience on the iPad. I think the lessons of these projects are many, but a few are building complete projects, tools that actually work, games that people can actually play, tells you something that you can't by just getting as far as you would need to publish the paper, for example. I think it's important to work in interdisciplinary teams that could be made up by interdisciplinary individuals or by groups that together are interdisciplinary. And as I've been stressing, basic research often enables the biggest applied successes. I've been talking very much about a sort of UC Santa Cruz specific view of this, but we recently organized a workshop called Media Systems that was aimed at getting a broader fields view of this kind of interdisciplinary research. It was the first project ever funded by the National Science Foundation, National Endowment for the Humanities, and National Endowment for the Arts. And it also had funding both from Microsoft Research and Microsoft Studios. There's a bunch of information about it online, but I also have a couple of copies here of the final report from the project if anyone's interested. And I guess my final note is to say, I think universities can expand what is imagined and what is possible for games. And I hope we will seize the opportunity to do so. Thank you.